Students. This video is connected to the October 29th remote class about network analytics. Earlier in the sessions, we were building the underlying driver of network analytics, which are called network data sets. Rules of the road is another good word for them. Taking any network like streets or rivers or any really polyline that is connected and dividing rules about how much time it takes or length it takes to go on each road, or whether or not you can take one way versus another, so on and so forth. And using those, like we did in the last video, to start maybe at one point and figure out the quickest or the shortest route from that point to another. There's one small thing I foolishly forgot to put in the last videos. I think when Eamon started stirring, sorry about that, I got a little sidetracked. But there was this point here under root where you see a barrier, a polygon barrier. And in your data set, you should see something that is called barrier. And so if we really quickly click on root and go back up to import data and pick the polygon barriers, say we're going to input barrier as the location. You know, the whole point is that it'll just mess with the data in such a way that it'll almost take every line, well, not almost, it will actually take every line that is under this polygonal barrier out of play. You actually can't use it, right? It's a true barrier. And so let's pretend that barrier is here. You know, we'll come in and we'll do the same run that we just did. You know, I think I was using C-score in the last video, but you'll see it needs to shift because now it has a point barrier that it can't actually surpass, right? So it'll follow the same rules, minimize crime, but it'll step outside. So point barriers, you can use them for all these tools we're going to learn, and really their main purpose is just as it sounds. You know, they just are you taking a certain number of roads or pieces of the network offline and making them barriers. So the next thing we're going to do is something called service area. Now, we learned a few videos ago buffers, right? Buffers are actually, 2 videos ago. That's when you measure the distance from something in a radial fashion, right? So starting here, drawing a radius and drawing a circle around it is buffer. Totally fine, totally passable tool, but it doesn't account for how we actually move through space as people, or as cars, or as transit. And what we're going to do here is something called a service area, which is probably better defined as a walk shed or a drive shed. And the only reason I don't call it that is because I don't want you to think it can only be used to measure driving distances or walking distances. It's really a way to use the same cost metrics we had before, time or distance, but instead of drawing a line between things, to actually draw the boundary around something where you could go in a mile, where you could go in sort of a minute. So let's come on up here to analysis, go back to network analytics, and pick service area. As previously, it will always take a quick second. Again, this is where I wish I had my Jeopardy music, so I didn't have to just sit here and stare at the nothingness. But here we go. It looks relatively the same. We have the sort of polygonal barriers, point barriers. We don't really have the roots anymore. We have this thing called polygons, which is eventually the output. Then we have facilities. So if I click on service area, the only big description or new things are this sort of direction and cutoffs that I'll talk about in time. But for now, we need facilities, right? We need things we're going to measure our distance from, things we're going to draw service areas, walk sheds, drive sheds from. And let's make it the delis, right? So, we'll pretend that what we're trying to do here is really show You know, if I had a bunch of delis that I wanted to patronize, maybe show me visually the service area of half a mile around each. You know, what distance could I cover? Half a mile on the road network to get to each one. That's the kind of question that service area helps you answer. So we'll load them and give it a second. They're loaded, they're points. Let's come on up here. Direction will not matter to those of you who are using the network data set we created in Pro. If you created it in desktop, this would matter because this means, am I measuring the service area moving from the center point outward or moving from outward inward, right? And depending on whether you're headed toward the facility or away, will really determine like the impact of the importance of those WUD ways. Cutoffs, we'll see in a second, have to do with when you want to draw sort of multiple rings. And we're going to start with just one, but before we can even get to the cutoffs, we need to come here just as we did before. And we need to choose the cost. And it's going to default to minutes, but I want to pick length. And remember, the length is measured in feet. And so let's just pick maybe, 2640. So exactly half a mile. So what we'd be saying here is we want to draw the area about 2,640, right? 2,640 feet, half a mile around each facility that will make up its service area. And you can do the same thing with a time for driving, 1 minute, 2 minute, 3 minute. It would give you the same equation. But we run it, oops, I think I hit a comma and it got upset. So make sure you don't have the comma like I did. Hit run, it's going to do its things. And there you go. Not a buffer, right? A polygon that follows the road network. Not to get too exaggerated and excited about ArcGIS, but super fucking cool, right? A very different way of modeling the world. No longer do we have these circles. We actually have these defined, intricate polygons which tell us, truly, right, this would be half a mile away. This is as far as you can get. And that point I mentioned before, right, if you start to do things like, commas, so 2640 and 5280, we're now going to actually measure half a mile and a mile. Oop, don't want a third thing, so get rid of that. Run. So it's going to do the same thing, except it's going to give you half a mile and a mile. Now we have a multi-ring buffer, right? How much is from 0 to half a mile, right? How much is from half a mile to a mile? Cool thing I forgot to show you in roots too is, the thing in roots where it said the actual root and the thing here where it says polygons, they exist in this sort of, feature data set here, but you can take that out whenever you want. You could right-click polygons and you could go to data and export and you'd make this into your own shapefile. Two more things to know, right? You can do this for time or crime score or any of those if you want here. And the only other thing to know is when you're drawing multiple polygons, you can choose whether things are rings or disks. What I've made are rings. What does that mean? Well, if I go to selection here and I select this, the outer ring, notice that it doesn't select sort of the internal area. Oops, let me turn off the roads. Right. Sort of looks like it's selecting the internal, but it's actually both borders, right? I'm selecting the outside, but not the inside. Versus if I came and cleared the selection and just selected this interior part here, I just select the internal. So rings, when you're digitizing these, means that each of the multi-surface area parts is its own shapefile. Versus if you created disks, as it shows, it would create sort of these concentric rings, where the first one would be 0 to 2640, the next one would be 0 to 5280. So that's surface areas. Super cool way to sort of expand upon the buffers and show the actual distance or time or cost it would take from an origin point.